Today I would like to present how to start writing autotests and not go crazy. So to begin with, a few words about myself. Let me introduce myself. So I have been an Android developer since 12/20. I'm an active contributor to some open source projects in GitHub. Also I'm author of a lot of articles as well as talks about Android developer. And currently my current position is a software expert at KasperskyLab, and the company holds me responsible for carrying out autotests in all our Android projects. So coming back to our topic, and the first question that you have, I think, why do you need autotests? For what? So let's think out together and just imagine. You're all developers here, almost, because maybe there are some HR people who can hire you if you ask a smart question, for example. But anyway, you're all developing a product. And what do you think? What is one of the most important metric of product success? You can learn from your seat. Be free, guys. What do you think? What is one important metric?
Test coverage.
Test coverage, okay. But what else, okay? What do you think? Usable, yes? Profit? Money, maybe? Something else? Maintainability? Yeah. So yeah, it's all of this really important, but one of the most famous metric now is time to market. Yeah. What is it? Time to market is a time during which you implement the idea of feature and deliver it to end users. And what do you think, how to reduce time to market? What ways we have?
Hire more people.
Yes, okay, very good. Okay, what else? Automated. Yes, what else?
Result from testing.
Yeah, so okay, so yeah, that's something about that. So yeah, to reduce testing time before releases and how to reduce time for regress tests, it's automated. Yeah, it's so logical. And it's so simple to say automated. But how to start? When you're at the beginning of your time-consuming auto test, you will face the following problems. First of all, that there is no concrete flow how to write UI test, simply. What does Google give us? Really, almost nothing. Some words about Orchestrator, Espresso, maybe some hello world, how to write with Espresso, and it's all, really. That's why there are a lot of different open questions, and each company creates its own bicycle. All of these things leads to the fact that you need to make a lot of efforts before starting to write UI test simply. So, further, I suggest to consider what questions has a developer. So, just imagine it's your team lead, and team lead tasks you to write a bunch of UI tests. So, you sit down on your seat, make a cup of coffee, and what next? You start to work, yeah, doing something. So first of all, you just fire a browser and put UI test in your Google, and what do you see? You face the first problem. It's a choice of tool. On the internet, there are a lot of different frameworks, tools, or something else, how to write tests. Yeah, but currently the main battle is between these two frameworks. It's Espresso and AdbServer. There are a lot of useful, really, articles and talks devoted to comparing of such tools. But shortly, Espresso is better, yeah. Why Espresso? Because it's a native tool, it's more stable and faster tool, and it's more convenient for a developer. Great. But sadly, Espresso is not so perfect. Espresso has problems, different problems. And what problems? First of all, just look at this simple test written with Espresso, and what do you see here? You see an API describing a so simple test with such verbose mode. But this test is doing only 3 simple actions. First of all, it's searching of the button. Second, it's checking the visibility of the button and clicking on the button. And it's all. Can you understand from this? No, it's unreal. The second unpleasant feature of any UI test frameworks, not only Kaspresso, is a flakiness. What is it, flakiness? Flakiness is your test passes 10 times in a row, for example, it's okay, but at the 11th attempt, it fails. And the reason and the point of failure is absolutely unpredictable each time. Each time. And it's a problem. It's such black magic, I don't know. Third, it's oh yeah, great. So you don't see. Anyway, it's a typical message, error message from Kaspresso. Yeah, it's absolutely understandable. So let's summarize Kaspresso problems. It's readability, flaky test, logging. But all these are not all problems of Kaspresso. Indeed, Kaspresso doesn't provide any convenient tool to interact with Android OS. And Kaspresso doesn't offer some architecture rules, some rules how to write your UI test. And all of this prevents you to write successful tests. Yeah. What is a successful test? It's a clean test, maintainable test, stable, without flaky, and so on and so forth. And now I want to show you 2 figures. First of all, first figure, it's how much time we spent to write our first successful test. So we spent 90 days. But during this time, yeah, we were struggling with all of these problems. And today, in my talk, I want to share with you all our solutions and knowledge and experience. And all of these will help you to write your first successful UI test within 1 day. Feel the difference. So, and our agenda today is we will analyze all of these problems and try to find the solutions for each. Okay, let's go. And the first problem today is readability. But it's not a complex problem today because the Cocoa library is coming to help us. So just to compare 2 pieces of code, first test is written with Kaspresso, and the same test written with Cocoa library. Yeah, it's absolutely another level of perception of what your test doing. Great. So, and you can notice using such thing like a main screen. What is it, main screen? Main screen is the implementation of pattern page object. This pattern is so famous in the world of autotest. And shortly, page object is a description of views located on the screen. And it's really very good that Kakao pushed us to write tests based on the pattern page objects. It's very cool. Great. The following topic is flaky test and logging. And the real adventure begins here. So I want to draw your attention to the fact that there are no clean and good solutions how to what to do with flakiness and logging. Okay, what do we propose here? So as you remember, Kaspresso doesn't provide any convenient tool to do something with it. That's why the logical mind here is to put Interceptor between a user, developer, and Kaspresso. But how does it look like, and how to put interceptors here? To answer this question, let's dive into Kaspresso. So, our example, our test written with Kaspresso, and let's to convert this test written with Kaspresso into a block scheme to simplify our perception of Kaspresso, like this. Yeah. So we're going to consider it step by step. Don't worry. First of all, it's an onView method. with view matcher passed as an argument. And on view method is responsible to get a special class describing a view with which you are working now. And the name of such class is view interaction. View interaction is the most important and basic class in Espresso. All actions and assertions are available over a view are available only through this class. And honestly, all actions and assertions over a view are available only through two methods of view interaction. It's a check method and perform method. And as you see, here we set implementations of arguments of view action and view assertion, where we can set rules for actions and assertions that we want to execute on the concrete view. Okay. So let's recall our initial scheme. And this view, with all we have discussed now, is transforming into this scheme. And as you can notice that obtain scheme suggests us wrapping perform and check method to manage entire Espresso like this. And wrapper, this new layer is an ideal candidate to put our interceptors. And now we can implement two kinds of interceptors to manage Espresso. What are these interceptors? So please pay attention to the next slides. So we shall now focus on view interaction perform method, but all we are going to discuss is absolutely identical to view interaction check method. And the first kind of interceptors is behavior interceptor. Behavior interceptor is responsible for two things. First of all, it's calling view interaction perform method as much as you need. And the second thing, it's a handling of result of view interaction perform method. So in the code, it will look like on this slide. And the first implementation of behavior interceptor is flaky behavior interceptor. Has been flaky behavior interceptor. So see the draft of implementation flaky behavior interceptor like this. And we're going to consider it in detail, don't worry. So first of all, you see that we just call our initial action. It's a view interaction perform method. Okay. This calling is wrought by try catch and do while. In case of error, we try to repeat failed action after some interval. And the count of attempts to repeat failed actions is restricted by timeout parameter. Great. But we have not stopped by only flaky behavior interceptor. Another popular reason of a failure, of a flakiness, it's non-visibility of view. So in most of such cases, you just need to scroll the parent layout to make your view visible. But Espresso doesn't do it and just throw the exception. Very friendly behavior, I agree, but it's the fact. So that's why the after scroll behavior interceptor has appeared to overcome this problem. One more reason of a flakiness, it's a random appearing of Android system dialogues. To overcome it, we have introduced a system dialog behavior interceptor. So, and this behavior interceptor works like a Russian matryoshka. Flaky behavior calls after scroll calls system dialog calls Espresso. And the handling of result is going in the opposite way. Okay? So, matryoshka, yeah. The second kind of interceptors is watcher interceptor. Watch interceptor doesn't impact on behavior of Espresso. But watch interceptor has an access to the additional information about concrete view and concrete view action. This additional information is located in the view action. And to get all needed information, we just introduce special view action proxy class. The implementation is here, and I want to highlight the main point here is on first line you see that we call all watcher interceptors and send them all needed information. And on the second line we just call our initial view action perform method. And that's all. So, and the main questions, I think now, is where all interceptors located. You know that we use Coco library to write our test, but Coco library hides all such Espresso classes as view interaction, view action, view assertion, and other. That's why we decided to put all our intercepting supports into Coco library version 2.1. But also we have created a bunch of a rich set of default interceptors and the convenient mechanism to customize it, and all of this we put into our special library. Okay, so let's just look at this common test written with Coco library. And the question here is, how do I enable all default interceptors? What do I need to do? And you just need to add only this thing, and all interceptors are working. Handling of your errors, handling of flakiness, additional logging, and so on and so forth. And you can customize library through a constructor. Great. So we've done it with flakiness and with logging, and now our another big area for creativity is the interaction with Android OS. As you know, Espresso doesn't provide any convenient tool. That's why we have created our special device class that provides a set of interfaces, and these interfaces give you opportunity to interact with Android OS very comfortable. So have a glance at some interfaces, for example, interface apps where you can install, uninstall, launch application. Now it's interface files where you can push, remove files. Network where you can enable, disable internet and something else, and other. But what does device use under the hood? Yeah, first of all, it's Espresso, but you know that Espresso is so limited to provide such things. That's why we also use UI estimator and ADB. But an attentive listener can notice that ADB is not enabled in Espresso test, and it's a problem. But ADB is very useful, especially for tests. And let me remind you how can ADB help you. So, for example, you can execute such standard commands like a push or pull files, tuning of system settings, and so on. Also, you have special ADB emo commands, but they work only with an emulator. And these commands are very interesting, really. Geoposition settings, simulation of calls, fingerprint emulation, and etc. That's why our the following part here is the struggle for ADB. So, small note that, for example, Appium test supports ADB commands. And how does Appium work? Why they support ADB? So the entire scheme of Appium, like here, looks like here, and the main note here that your application is installed on your device, but your tests are installed on the desktop. And that's why your tests can execute ADB commands, because they are on desktop. But how does Espresso work? In Espresso, you see that your application and your test application that contains your tests are both on the device. And that's why you don't need in the desktop. And that's why you cannot execute ADB commands from your test. So, and the logical question is how to revert the possibility to execute ADB commands. And I think that it's so simple and obvious. It's just to revert back the desktop in this scheme. and establish a connection between a desktop and a device. So Google has voice in such scenarios, and they just introduce special IP. It's 10.022, and the trick is next. Then you input in your device's browser 10.022. Android redirects you to your desktop's local host. That's why you have an access to your desktop from device. So it's great, and that's why we wrote a so simple Python server. Really in 5 lines. For the first time it was enough. And organized a simple client-server connection between the desktop and the device. And it works, it's okay, and it's great. But no. Yeah, okay, everything was perfect. Yeah, until we met the following row for the first time: disable the internet. And shortly, disabled internet turns off a possibility to communicate with mentioned address, and it's a problem. So this discarded fact depressed us. We were bored, but after some time, we decided to begin to read documentation again. And after some time, we found out the following thing: port forwarding. What is it, port forwarding? So, look at this example, ADB forward TCP 61, TCP 85 for short version. And just imagine that you have desktop on localhost with port 61. You have a device on localhost with port 85. You have any connection between a device and the desktop. And when you and the trick is the next: when you execute ADB forward TCP 61, TCP 85 on your desktop, then you can input in your desktop's browser localhost 61, and you get in on your device's localhost 85. And the main note here that the kind of connection can be absolutely any, really. It may be Wi-Fi, Bluetooth, I don't know, USB, localhost, any. So how can this ADB forward help us to find a solution for our task? So be patient, please. It's not. It will be not a very easy slide, but we are going to consider it step by step. So first of all, on the device, we set up our product application and test application that contains our test. Our test application set up a simple socket server on localhost with port 85. On our desktop, we execute ADB forward TCP 61, TCP 85. And the most important intriguing part is coming here. We set up a socket client on the desktop on localhost with port 61. And because of port forwarding, this socket client is exactly the same as a socket client on your device on localhost with port 85. And the simple socket server connection between a device and desktop is possible. So to summarize, we can execute ADB commands in your test with the condition that your device must be connected to a desktop through any kind of connection. It doesn't matter, Wi-Fi, Bluetooth. Here, for example, it's localhost. So great, we have created a bunch of default of special interfaces that provide you opportunity to interact with Android OS, thanks among others to restored ADB. And the last part here is architecture of test. So you know that when a developer's team start to write code without any recommendations how to do it, the outcome can be absolutely unpredictable. That's why it's a problem, and what do we propose? So first of all, it's a pattern page object I mentioned earlier. Yeah? As you remember, it's a description of views located on the screen. But the main note is page object doesn't contain any states and business logic. It's very important. Keep the single responsibility principle. And the single responsibility of page object is just logical grouping of your views, and it's all. Anything it's, but the presence of helper methods on the other hand is okay. You have no restrictions because you know the size of your mobile screens and the size of your web screens are absolutely different things. And the last thing is try to use as less abstractions as possible, because you know in the process of writing of autotests will take part not only developers but also, for example, autotesters, testers, and it's very important to try to keep things as simple as it's possible. So let's recall how Cocoa library implements the page object. And all of this is possible thanks to special screen class of Cocoa library. Great. But another thing, it's a common code style, and this thing I'm sure it's not considered anywhere, really. And what do we offer here? So just look at the simple example written with Cocoa library. And here, can you predict how your test correlates with the test case on which this test is based? Or how many are there steps in the test case? You don't know. But what can you do here? You can put special marks like first steps, second steps, and you can correlate your test and your test case. For example, another desirable thing is to output more log information, and in logs we want to observe what step is running now. Yeah. So it's possible. Also, we just add a special log, and it works. Okay. And for example, another thing, desirable thing is to catch all potential exceptions of each step. And in case of exceptions, we want to output additional logs, make a screenshot or something else. We're engineers, we can do it. Why not? Like this, yeah? It works. But I think that you notice how our simple test is transforming into such mess. And this code is non-maintainable, really, and it's a problem. That's why we have created our own special DSL to resolve this task, and this DSL is looking like on this slide. You see, the main thing here is the function stub. This is doing a lot of work under the hood. For example, it's additional logs, it's handling of flakiness, catching exceptions, and so on and so forth. And now our test contains is consisting of such steps. And just evaluate the improved readability now of your test. And for example, it's logs that the method step produces. And here you can see what step is running, how much time it took, and other information. So I have a great pleasure really when I read it. Another additional features of step, it's for example, feature scenario. What is a scenario? Scenario, it's a group of tests that are repeated in almost all tests. So you just create special scenario, and first example is first run wizard scenario. I think in all cases this scenario is. Another interesting thing is inner step. For example, in your step you want to highlight each assertions, and that's why you can do it with inner step. Then the following thing what I want to consider here is environments preparing. So there are a lot of test cases where you can where you must prepare your device. For example, turn off the network or maybe something else. And what can we do? We can add a zero step, for example, turn off the network. And the main note here that after your test, you must restore device's state at the beginning state. It's very important thing, and it's very important thing to avoid flakiness for following tests. So okay, we can do it, and we just add a 8th step, like a turn on the network. Yeah, but to be honest, yeah, 0 step and 8th step are not part of the test case, or are not part of the test case. It's all about the preparing of your device, but it's not a test. So we think that it's also a problem, and that's why we have decided to extend our DSL to the next form. And you see before method, after method, and a run function where we put all our steps. Great. So, short architectural summary. First of all, it's a use page object. The use page object doesn't contain any business logic and states, but helper methods, the presence of helper methods is okay. Try to limit the count of abstractions. Restore device to the beginning state after test execution, and write your test with human DSL like on the previous slides. And it's all. And think that you have only one last question is where all these solutions. And for example, for readability, the solution is CookBook library. But what about these guys? So we decided to join all our solutions in one special library, and the name of such special library is Kaspresso. So Kaspresso, you know, yeah. So Kaspresso is not only for resolving all these tasks, but Kaspresso also contains more additional interesting feature like working with doc log and something else. So all of this you can read by these references, be free. And at the bottom line you can join the chat to ask any interesting question about Kaspresso or AdbServer. So yeah, AdbServer is about our restoring of ADB in Espresso test. And here are my contacts. You can call me, write me, be free. You're welcome always. And that's all. So thank you very much.